Okay, 12.2 part 3. So continuing our discussion of expanding powers of binomial sums, now we're going to find the power of, or we're going to expand the power of a binomial difference. And the only thing that we really need to do here is we need to convert this into a binomial sum. So we have 8 minus 2b to the fourth power. So instead we're going to write it as a sum, so that would be a plus negative 2b to the fourth power. Once we do that, then we can use the same way that we did a binomial sum. Okay, so a is our a term, and then negative 2b is our b term. 4 is our n, and of course we start with r equals 0. So our first term would be 4c0 a to the fourth negative 2b to the 0 power. And then I would just move on from there. My powers of a are going to decrease by 1 each time. My powers of b are going to increase by 1 each time. So now we've got 4c1 a to the third negative 2b to the first plus 4c2, and then that would be a, let's erase that, a squared times negative 2b squared plus 4c3 a to the first times negative 2b to the third plus 4c4 a to the 0 power negative 2b to the fourth. Okay, so now I go through and start simplifying, and I can either use Pascal's triangle or calculator or whatever. My coefficient on this one, 4c0, that's 1, okay, times a to the fourth times negative 2b to the 0 power is just 1 plus 4c1 is 4 times a to the third times negative 2b. Negative 2b to the first is just negative 2b, obviously, plus 4c2, which is 6, a squared negative 2b squared, which I should go ahead and do. So negative 2b squared would be 4b squared. Okay, negative 2 squared is 4, b squared is b squared, plus, and then 4c3 is 4 again, times a to the first, times negative 2b cubed is negative 8b cubed, plus 4c4 is 1 times a to the 0, which is 1, times negative 2b to the fourth would be 16b to the fourth. Okay, so now once I simplify all of that, 1 times a to the fourth times 1 is a to the fourth, plus 4 times a to the third times negative 2b actually gives us negative 8, so I'm going to go ahead and change this to now a minus, so minus 8 a to the third b plus 6 times a squared times 4b squared. Well, 6 times 4 is 24. And then we've got a squared, b squared. And then the next term, 4 times a to the first times negative 8b cubed, so that's going to give me negative 32ab cubed plus 1 times 16b to the fourth would just be 16b to the fourth. Okay, that takes care of that. So now on to the last part of 12. So the last thing that we're going to talk about is finding the coefficient in an expansion. So we're just going to figure out what is the coefficient of y to the sixth in the expansion of 8 minus y to the eighth. So we're not going to have to do the entire thing. We're only going to find where we have y to the sixth power. Well, y is my b term, so we want to figure out when is the power of b 6. So let's look at the sum notation of this. So we would have 8c to the r power, or excuse me, 8cr times 8 to the 8 minus r times negative y is my b term raised to the r power. So if I'm looking for y to the sixth, that means that I want to find out when r equals 6. So the term that has y equals 6 is when r is equal to 6, that I know everything else. So that would be 8c6, 8 to the 8 minus 6, which would be 2, so 8 squared, times negative y to the sixth. Okay, well, 8c6 is 28. Okay, I can either use Pascal's triangle, or I can use formula or a calculator to figure that out, times 8 squared, which is 64, times, and then negative y raised to the sixth power would be y to the sixth. We have an even coefficient, or excuse me, an even exponent there, which means that we're going to go from negative y to positive y to the sixth. So multiply that all out, and we get 1,792 y to the sixth. Okay, so y to the sixth power. So that means that my coefficient then, of course, is just 1,792. And that takes care of 12.2.